I'm good. Hey, David.
Hi, everybody.
What's going on? We are live with our new day, same time, weekly stream, formerly on Thursdays, now on Wednesdays for Epiphyte. The reason why we did that is because we wanted to accommodate the UT net team, DAC team's schedule, because that is where we're going to be building this next version of Epiphyte. They missed the last 2 weeks, so we'll catch them up a little bit at the top of the call. I think we'll have Ling join, who's done some great research on the monolith. But why don't we just do a little bit of basic catch up before I do that? How's school going for everybody? Thomas just Tommy mentioned, but Will and Charles, how's class going?
All good, all good. Just TAing, do my work, lab work, just same old, same old.
Very cool.
It's going well. Got Expo. I think Tommy probably talked about that as well. It's been pretty stressful just this week, but going well otherwise.
Yep. Okay. Well, great. Well, let me catch you up on a couple things that we talked about last week. And one of the major ones again. Oh wait, somebody else just joined here. Here's Ling. Awesome. Hey, Ling.
Hey.
How are you? So for the agenda for today, there's a good number of things to cover. I wanted to just catch the UT team up on some of the design ideas we had over the last 2 weeks. Then I thought I'd give you the floor to talk about some of your monolith research, if there's anything to share there. And then, Will, it'd be good to talk about what we might be able to do in the near term around adding PEI to a tiny monolith core and maybe testing it at UT. And maybe you can also elaborate a bit on some of the fancy, awesome equipment you have at your lab that's relevant. And then a little diversion, I wanted to share with you guys some of the interesting clay options that popped up for me in the last week and a product I found that could be pretty intriguing if time allows. How's that sound, guys? Anything else to add to the agenda? All right, cool. And I'll be in Philadelphia next week, David. So looking forward to seeing you in person. All right, cool. All right, so let's start with that. So I just want to give a bit of an update to the UT guys about what we were looking at last week. So I can't remember if you were, let me just find the right picture. I can't remember if you guys were here when we talked about the idea of going vertical with the chimney. Oh man, where did I put that image? Give me 1 second here. All right, I'll just show this one here. So we had this idea, disregard all the other stuff, but we were worried about how we get the air to flow inside the closed chamber. And we were looking at like, what kind of fan could we put in there that wouldn't melt, that could be exposed to, pressure and heat. And then I just thought of the idea that we might get a little bit of help, at least if we went from horizontal to vertical, so that the heat would rise naturally. I think we also think that we probably still need something to push it along, and we might have further thoughts on that today. But we started to think about that, and I was like, oh, I love the metaphor. It's almost like a chimney that takes stuff out of the air rather than puts it in the air. And that got me thinking about, rather than looking at HVAC as our sort of basis of equipment for these materials, what other, could we actually look at the chimney world, the chimney stove world, and see what parts they have available that we might be able to actually buy off the shelf to make it. And there's actually quite a bit of stuff in there. It looks like I lost the picture from last week. Sorry, guys. I'll find it in a second. But there's basically several parts from a chimney, and there's even dampers that are high heat. There's these other slip materials that this one kind of shows it, that can be used, and they're all, they're all for airflow and high heat, and they're relatively cheap. So all the parts that I looked at, come in under $500 for all that equipment. And including one of these guys here, which is like I'll find that image in a second. But if you can see in the middle there next to the fan, there's sort of like a divider link that is a tube that has another 6-inch diameter hole on the side, which we might be able to go ahead and add the damper and the fan to that on the side, and then have the heater on the bottom below the monolith. So I'll find those pictures in a second, but that was kind of our thinking. So let me know if you have any questions about that idea.
Can I go ahead and ask the first question, I guess?
Yeah, go for it.
Because I don't think I've seen the chimney design. I like it. I just wanted to ask, when it heats, will it be from the bot? So it's at the bottom where it heats, and then it will build up, so the airflow will go upwards, right?
That was the idea.
Okay. Well, do you think it makes sense to put the vacuum pump at the top then as well to help facilitate that like purge of hot air coming out of the system? I don't know, just kind of like a little brainstorm.
I don't know. What do you guys think?
Unsure what you mean by this question. The vacuum pump is on when. Oh,
During the heating, right? It would be on and then
yeah, you have a good point. Yeah, makes sense. I'm open to that. We'll have to find a way to hook it up properly and like jig things so it's stable. But yeah,
okay.
David.
What's the sequence of events here? Are we heating it up first, and then we stop doing the heating and then start pumping the released CO2 out, like in 2 steps? Or does it all happen together?
Will, on that part, we had talked a little bit about how you can kind of combine, to a pressure thermal swing is, where you could do that. But I think there's some concerns about a really high vacuum. So the vacuum would probably maybe be used more just to evacuate the tube rather than actually pulling the CO2 off of the monolith.
Sure.
So if it's that, then we could probably do heating. And then once heating stops, you go ahead and do the vacuum just to purge the chamber. But I don't know. You explain what your thinking is on that.
Yeah, so I guess my original thought was that we would heat and pull vacuum at the same time if it's possible, which I think is totally doable. But we just have a pump that, I don't know if I had mentioned this to you, Chris, but that does not use oil. Actually, hold on. So let me turn on my cam. I think. Can you guys see me? Hi.
Yep.
Hi.
Originally, it was an idea that I had that whatever the pump that we're using, it does not use oil. So the exhaust gas or the gas that's being pulled through the pump, it doesn't go through any oil, and it just goes straight from inlet to outlet, and then that outlet we go store that somewhere. But it happened at the same time as the heating, so we heat and then also pull vacuum to facilitate both. If that causes too much of an issue, we could do like a cycle thing, like David has suggested, where we like just heat or evacuate first, then heat up for a minute, and then pull the vacuum again at the end after it's done heating up. But I think simultaneously is the best option.
Okay. Did you have an idea, Will, for a particular kind of vacuum for that?
Yeah, just some vacuum that can come down to, usually it's like negative 30 millimeters of mercury. Those are like kind of like the little weak pumps, but that would be more than enough for our system, especially if we're heating it as well. So that little picture you had there, I feel like one of those pumps would be more than enough to be able to like get the job done for us.
Okay, cool. They're also cheap, which is nice.
Yeah. Yep.
I just want to show you this, guys. This was the image I was trying to show before. Let me see if I can present that. So these are the components we were looking at. If you can see that, just in the next slide. So it's got all these. It's got these, 24, 36 pipes that are 7-inch, 8-inch, 10-inch, 6-inch interior diameter. They also have these double wall chimney pipes. So it makes it less hot to the touch on the outside, but we could also insert some form of ceramic tape or something that might be a good insulator. It's got this kind of T-pipe. This is a great little piece. Dampers, which you can add an actuator to. I called up the company. They said that wouldn't be a problem. So anyway, it just looks like we can kind of, from parts there, probably put something like this together in the ways that we thought. And again, it's a lot of that is because the plastic that we had thought about is extremely expensive, as well as ceramic. At least the stuff that I found, it's like $1,000 for like a piece of that dimension just for the pipe. So anyway, that is an issue, but I think this looks good. So anyway, we're leaning towards that. All right, cool. All right, Ling, did you want to talk a little bit about some of the math and exploration you did around the monoliths and what we were concerned about or what we were trying to figure out?
Yeah, sure. Let me see if I can find my article. So I am pretty unopinionated on um the heating and the vacuum. I think like I'm familiar with the process. I've never run through it myself. So I think I'm open to like testing it. Like if I were to do it myself, I would have to test it and see how it works. But yeah, if someone else has a better idea on how to do this, we could just go with that. Okay, give me a minute.
Sure. In the meantime, guys, there's a little bill of materials spreadsheet that we created to put down some of the components that we're considering. And I just added that in the comments. Or let me add it in the chat. For some reason it didn't add. So you can take a look at that. Just a good list of parts we're thinking about.
Oh man, I don't know if I can share screen.
Did you look at the present button on the bottom?
I'm in the app, so like not on the computer, but I'm on my iPad, so I'm not sure if I can pull
You
it
want
up.
me to share it?
Yeah, please, and then I'll just direct you.
Okay. Is that the thing you put in the Discord?
Yeah, can you pull up that article?
Yeah, let me grab it.
I don't think someone who's experienced with these monoliths will really need to read this article, but if you're unfamiliar with like the physical get it I don't have a good physical feel of these monoliths, so the article is really helpful for me, and it's a little complicated, but overall what it is, that picture is really good. It's a two-part monolith, so to speak. The inner part, the inside of the annulus, has a different CPSI density than the outside. And some of the later plots will show that if you adjust the density of the outside or the inside, what will happen to the velocity of airflow. And that was really helpful for me. Like, I have no idea what a certain number of like airflow velocity feels like, but it gives me an idea of it increasing by like 2x or 3x or something. Can you scroll down maybe until we get to one of the plots? Yeah, so there's math. My math is quite bad for an engineer. Let's see, pressure drop. Let's keep going. Yeah, like one of these. Okay, so when you change the core size, and you'll have to read the text surrounding this, because core size can refer to the diameter of the inside round area, or it could be like the CPSI on the inside. Actually, can you zoom out, Chris? Let's see if we can see some texts around it. Core size percentage versus, yeah, it's above. So above it explains, and then if you hold the core size the same, permeabilities are being kept constant. So I'm thinking that permeability is referring to the CPSI, and then they just vary the size of the diameter, and as the core size. Okay, let's go to the graph. Go down a little bit. So as the core size increases, the core velocity is decreasing. Okay, so maybe this will have to do with the cell size for each of the areas. Anyway, so if you go through this and think about, like, for the audience, probably like the engineers probably don't need me to explain this. If you go through this and think about it, you can think about the proportions of increase or decrease as certain parameters for this structure is adjusted. Okay, so I don't really have like a lot of direct takeaways from this article, but what I said on the Discord was that we should just aim for a lower CPSI so that we can get uh like low back pressure. So this article is very proud of the fact that these ceramic monoliths, they're using catalytic converters. They have low back pressure, and I like that it's giving that support. It gives me more gives me more confidence in that. Likely, no matter eventually, like whatever CPSI we pick, we can make it work. But we want to just avoid risk, and if we see that like something like 100 CPSI can work really well, then we can go for something denser later on.
And they
Um,
seem cheap enough, like you mentioned, Ling.
yeah, we can get more than one.
I'll get a few of them, and we'll see. But
Yeah.
Will, this is your territory. I know you work on the monoliths and stuff. And Kirsch, I did post a little message he sent where he didn't think that 100 CPSI would be an issue for this application based on his experience. But Will, curious to get your thoughts since you play around with monoliths.
Yeah, I guess my first question, Ling, was: is this monolith? Is it alumina based?
Yeah,
It is.
Oh
Okay.
no, ceramic.
ceramic aluminite.
I think it's cordiorite. It's called cordiorite. It's a type of ceramic.
Cordiorite. Okay, gotcha. So I'm not too familiar with what that is exactly.
Me neither.
I can look it up. The only issue is that looking at the preliminary stuff for like the PEI, it can, at least from what I found so far, the easiest way to get PEI for the adsorbent to graft onto a monolith is just right onto alumina. It'll basically just like stick right onto an alumina surface. So my original thought was having an alumina monolith, but cordiorite, how do you spell that by chance?
So are you on the Discord?
Yeah, but I don't know. What's the page again, or what's?
So you can
I'm not
just
super
look up.
familiar.
You can just look up ceramic monoliths, and most of the ones that are available, they're available as cordiorite. It's like CORDIE RITE, something like that.
Okay.
But yeah, it's a type of ceramic.
Gotcha. Okay.
I see that most of the Alibaba ones, they're available up to like 600, sometimes more PSI. So I got scared because I was like, oh, are we gonna be able to find one that is more porous? but yeah, like there are 100 ones, and it's good to hear that 100 CPSI doesn't have any problems. We can't get anything around there. And it's good to get a different one so that if we wanted to see what the surface area, or like if we want to do any testing on if we adjust the parameters, we have two, we can easily swap it out and see that like a denser CPSI will result in what, like, because we'll have to consider both airflow and surface area. But it would result in a lot of learning.
Okay.
Anyway, it's not directed towards you, Will. I'm just talking in general. But
Yeah. Sorry, I just wanted to say that I looked up the cordiorite, and it looks like it's not just an alumina-based ceramic. It has like it has like magnesium oxide and then the silicon as well. So I do think this could still be used to be able to graft PEI onto. I just don't have any myself, like in the lab or to test it out. But I do have alumina stuff that I could use as a preliminary thing to try out first. So, but I think it'd be applicable to the cordiorite though. So I think we're still in like a good plan.
Are you saying aluminum or alumina?
Alumina, yeah, AL3 or AL2O3, I think technically is the aluminum oxide. Yeah.
Okay, I see. I'm not very familiar with. I'm more of a plastics person, so I'm not familiar with any of these.
It's a hard white thing. It's ceramic, and they used to use it like for microwave integrated circuits because of its electrical properties, but it's also a good insulator, but it doesn't transfer heat very well.
Okay.
Yeah, I just looked up. There are quite a few alumina honeycomb monoliths as well that I'll throw them in the spreadsheet, but it looks like those are pretty common, I guess.
What's the pricing on them?
It's not that bad. The one I'm looking at right now is $37.42 for a. It's smaller. It's a 97 millimeter diameter, but it's not, an order of magnitude greater or anything like that. So, and it's 138 millimeters long. So there might just be two varieties of the same kind of thing. That if alumina is better, then if the price isn't crazy, then we can potentially look for that.
Someone mentioned that so the process that Kirsch described, which is like wash coating, is available in one of the articles. So in my Discord post, which is a few posts up, where I linked that article. I also mentioned that the wash coating process is described in one of the articles being referenced in that article, and I wrote down the number too. It's like 20, 27, 28 or something like that. So you can look at that reference. I'm not like familiar with how reputable that article is in particular, but it's there if you want to look at it.
Okay, I'm trying to find it. Okay, cool. So, thanks, Lang. So it's good that it seems like we feel better about the resistance being a non-issue, but we should probably just buy a few different sizes, test out if there's any performance difference between different CSPIs or PSI. But Will, just kind of over to you a little bit. I'm curious, when you were over at my house, we talked about doing some basic, simple tests with monoliths with PI that you have. Mm-hmm. And I wonder if this could be an occasion to kind of talk through that a bit, but also you could tell us a little bit about some of the specialty equipment you have at the lab that's sort of pertinent to this kind of testing. And it sounds like it's kind of unique to where you guys are. Not unique, but not every university has them. So I don't know. You want to give us a sort of a little bit of an overview of that?
Totally, yeah. I can start by talking about the instruments we have. So we have 3 adsorption instruments, and what you can do with those is basically dose in different gases. You have to do one at a time. So either like look at nitrogen, N2, or CO2, whichever one, and you can get this data called isotherms, so at a constant temperature, and you can dose in a gas at different pressures and then see what the uptake is for that material that's in the sample cell. So, for example, we can look at surface area, and there's stuff that you can do at cryogenic temperatures with liquid nitrogen to get a thing called BET surface area, and that's used all over industry, mainly for powders, but we could do that for some piece of ceramic. And what my plan was originally was to take like a control of just regular ceramic by itself and see what the surface area is of that, which I'm expecting to be super low because it's not going to have much adsorption for nitrogen at cryogenic temperatures, and then try and do the wash coating with the PEI that I have in lab and just see how much I can get onto there and how much uptake I can then see with CO2. Just as like a preliminary thing to see how well the wash coating process could be done with just like run-of-the-mill alumina stuff that we have here in lab. So yeah, that's kind of the big thing that we can do is gas adsorption analysis, and it's pretty big because not all the universities or not all the labs here on campus have those. I think we're one of the few ones that even have at least one adsorption instrument.
Do you think that's something we could do relatively soon, Will, just to sort of play around with PEI, one of your little mini monoliths, and go ahead and sort of test that out? Do the work?
Yeah, totally.
Right.
Yeah, I was actually planning on doing it myself. I just didn't do anything yet just to make sure we were all on the same page if we were moving forward with that. That's why I was asking about the cordierite mineral monolith instead, just to make sure we're still going to go on with that. But I can get some preliminary results with that maybe within 1 or 2 days.
Okay, cool. I might come join. I was talking to Tommy before we started that I know you guys are meeting up tomorrow for the DAC team. Mm-hmm. I might be able to swing by for part of that with my son before I take him to soccer practice. So maybe we can talk a little bit about that. But I think that would be exciting. Your monoliths, I know you're just testing the absorption, desorption. Actually, no, never mind. That's not relevant. Anyway, that'll be cool to test out with and get going on.
I did want to ask actually in relevance to like the next meeting and talking about doing that and like talking about that at the meeting. Do the undergraduates need any sort of certification to participate in that, Will? Or is that something that like they can be present for to watch without that, or like what's up with that?
Yeah, if someone just wants to watch, it's totally cool. They can just be in lab, but if they want to get their hands on, I technically need to do like a safety training. There
Okay.
are a few members who did that with me last semester. I don't know if they'll be joining this semester or not, but it's a pretty simple process. But yeah, there's like a safety training, that lab safety stuff. Basically, what you have to do when you take like a Gen Chem course or whatever, they just go through all like the standard of like, where's all of, like the fire extinguishers at, all that stuff. We've seen that like recorded for our lab. But you can come watch. Yeah, it's not a big deal.
Yeah. Just to not stall this one, we can do the training another time. But let's put a pin in that so that we can have some of the undergraduates also participate and help you out, so you don't have to do everything.
Cool. Yeah.
Yeah, that'd be great. Awesome. One other thing that came up on the Discord last week, that one of the folks who sometimes chimes in here on the comments and is on our Discord, I wanted to ask, I thought it was a pretty cool idea, was, let me present my screen here. Where's my Discord? There we go. Oh, no, let me just share my old screen. Okay, so this was what he shared, Malks. He had this idea, if we're worried about heat distribution through it, did you want to run like a nichrome wire, through, every 20 cells or something to sort of heat it up conductively? Don't know if that's an idea that people think is worth pursuing, but figured I would at least use this as a moment to rule it in or rule it out, since he shared it.
Would that like damage the monolith itself, that heating being that close to it? I don't know if that's
Super high heat, that material, it seems. Tolerance, it seems to be well below our threshold here, but I don't know.
I don't think the monoliths will get damaged, but keep in mind that it is ceramic, and ceramic is pretty low heat conductive. And additionally, in the cells where you're doing this heating, you're likely not going to get that much airflow. Well, actually, maybe you will, depending on how thick the wires are. Because I know sometimes they're super thin. I'm not sure what the effect is if you heat the nichrome wires up to like a few 100 degrees, and then I don't think the sorbents will get damaged, but they may not capture it as effectively. I have no idea. Something.
It's probably worth being patient and heating it up kind of slowly.
Yeah. So my response to this was that I don't want to like rule it out if anyone is curious, because I've never done this, so I don't know that it would not work, but I would unit test this with like 1 or 2 threadings. And if you find it really laborious to set this up, it may not be worth it. Like you should take like manufacturability or whatever into account when you're setting up something like this. So if you find that like, oh, threading through is not a big deal, yeah, go ahead and test a few threadings and see how the nearby cells would heat up.
Yeah. So worth considering. I guess we can see how effective we are with our option we have now, but even if it's like auxiliary heat or whatever, but just wanted to get people's thoughts on that.
I think that's something that we could reasonably test here at the UT DAC at some point. Maybe not immediately, but once we get like that, but making an extra one of that. Do you think that's possible, Will? Think it's possible? Cool. Awesome.
Cool.
Yeah, I'll write that down put a pin in that.
Cool. Yeah. I mean, I think we could talk about this a bit tomorrow, but I think because these things are relatively cheap, I might, and you have your monoliths to do the PI testing, but it would be cool to just go buy a couple of these, either order them from Alibaba or go to an automotive, there might be somewhere you could actually buy at retail here. Just have a few of these different monoliths on hand that are the size that we're thinking about to kind of play around with. We could run some wires through it, heat it up, whatever. I think it would just be good to have it in your guys' hands relatively soon. So if we find the one that we want, there was a bunch of options I put there. They're all kind of similar thing. There's like a zillion options to buy. So
yeah, I've been thinking like we may want to figure out the housing, but maybe we don't have to figure out the housing first. Maybe we should just get you guys to unit test the monoliths as like separately, because it's not a big deal, and then you can learn a lot from the heat transfer properties, which will be helpful to us deciding stuff later down the line. We can just buy more if it's not the right size or shape.
Yeah, definitely. All right, cool. And as for the housing, I mean, I'm trying to think how we make a decision on those chimney parts that we looked at. You know, it's pretty simple, cheap. You know, I wonder if we should just sort of go for it. I don't know. How do we make a decision on that? You know, we have to buy something. We want a tube of some sort. Seems like there's a lot of good reasons that point in the direction of buying those parts. I don't know.
Even beyond like it being cheap now in terms of like testing it, like why not buy it? I think that's credit to like what Epiphyte's end time goal is, right? In terms of being
Oh shoot, we
Exactly.
lost them.
I think we lost you. Go ahead. Yeah, that applies for everything across the board. But I think, you know, going ahead and I don't know, what do we guys tomorrow? If I'm able to swing by, you'll see on the spreadsheet that I popped into the chat there that lists all the things we're thinking about. And under the tube piping, you'll see links to those chimney parts. You know, but I think it's a matter of us just kind of going for it because we know we can fit a monolith in there. There are dampers for it. You know, it's 6-inch or 7-inch in diameter. So I think it's just a matter of us sort of pulling the trigger and trying to make it work. I think we can probably make a decision on that relatively quickly. But I want you guys to, you know, weigh in and let me know what you're most comfortable with. We lost you there, Thomas. Sorry, you were in the middle of something and you dropped off for a second.
I don't know where I dropped off, but basically they're just saying that like it being cheap it like has value outside of it the now, you know, like outside of the now testing. Like that's part of the goal of Epiphyte. So that was all.
Yeah. So
I don't think we should get anything smaller than like 6 inches. I think we should get something just like if we can get 8 inches, if that's the biggest one, we should just get that.
1-inch increments, I think, from 6 all the way up to like 18 or something. So they're all available. We could get.
Oh, okay. That opens up a lot of options. Yeah, I'm still thinking about the air recirculation problem, and it's hard. It's hard. Like, I think we're just maybe just gonna order parts and fail a few times. It's usually like how I go about it.
Yeah, and
the best part of engineering.
Yeah, Will and Tom and Charles, that was a thing that I can't remember if that came up while you guys were off, but it's like we are just trying to think like what's the best way to circulate air in a kind of closed hot chamber like that, with a part that won't melt, you know, or malfunction, you know. So that is something we're trying to figure out.
Sorry, go ahead.
So no, I was just gonna say to your point about failing. The DAC team looks like it's from what I've picked up on of recruitment and these first 2 weeks of talking to students and like that. It's gonna be a whole bunch of students, like a whole bunch, like 25 is what I'm maybe more. So don't be afraid to throw multiple stuff at us that you might think might fail. There's no harm in just putting a sub team and having them try it and do their best. And so don't be afraid of throwing stuff at us that we can't. It's not like all of us need to be on one thing at a time. So don't be afraid on time constraints to try and fail.
Sweet.
So the air recirculation issue, it is that I was thinking of convective heating, and if you have a heat source for convective heating, then you need to have a way to recirculate the heated air so that it will reach all the surfaces of the monolith, like inside and out. That's where all the coating is, right? And like what's it called? Somewhat turbulent air is important for distribution of heat throughout the chamber. And if you have a monolith separating two areas like bases in the chamber, then that part is going to be high resistance, the highest resistance. Even if it will not be like super high low resistance, it will still be the highest resistance, and we're gonna need something to push the air through the monolith to the other side so that it can heat the surface on the other side of the monolith at least. So we're thinking of like a fan of some sort that blows the air across to the other side, but then it comes back through the same monolith. And yeah, I have no idea how it's gonna work, but with something that is of a bigger diameter, it's going to be more feasible to do recirculation like through the thing and then around, coming around on the other side. I think.
Go ahead, David.
What if we put in a separate small tube that goes around from the upper chamber above the monolith and recirculates the air through this tube back down to the beginning?
Like a bypass.
A bypass, yeah, assuming that the airflow isn't too high. It can be a relatively small tube, and it'll be warm, so it'll have to withstand the heat, but it could just be a metal pipe or something. Then all the air would go through the monolith holes in the same direction at least, and we wouldn't have the ambiguity of trying to figure out, well, is it really going to come back through some and go forward through others?
Let me, can you talk us through that a little bit, David? Disregard that weird damper that's sitting sideways on the side, but where would that tube go based on what we're looking at? That's the monolith in the middle there.
From that space above the monolith, down and around to, I guess, below the duct heater.
Yeah. So it's basically, it gives an alternate path for the air. And it doesn't have to be like as big. It can be smaller, and then the air will just go through it faster.
Could you just have like a big tube next to it? Like basically just a tube right directly next to the monolith?
Well, on the outside of the pipe.
Oh, on the outside of the tube.
Yeah, outside of the pipe. And the thing is, you'll need a small fan someplace. I don't think that just the passive convection would cause it to come back around through the tube.
Okay.
Maybe we just put the fan on the other side together with the heater, and then we put the bypass below the fan. Make sure the damper is on the outside of the fan.
Yeah, that would work too, unless the little fan kind of gets in the way of the big fan when we're doing the capture phase.
I was just thinking the big fan doubles. We don't need the little fan anymore.
You could do that too.
But then the dampers, like you'd have to put the damper on the other side of the fan, right? Because you wouldn't want to.
Yeah.
You wouldn't want to open that up.
Oh, yeah, correct.
Yeah, the big fan could do double duty as long as you can adjust the speed, because for the heating part, you probably want it to be sort of low speed.
Okay. So our buddy J3ANX is endorsing your idea, David. So just letting you know in the comments. Thanks.
Thank you, J3NX.
Yeah. Okay. Well, that's. Oh, where's my camera off here? Sorry. So okay, cool. So I don't know if you guys want to. We can kind of napkin that a little bit, I guess, in terms of how that will look. But that seems doable. Any other questions or ideas from anybody? But particularly from. It's music to my ears as well, Thomas, that there's going to be a lot of people involved, and there's a lot of subtasks we can divide into. So I think we can start to project manage that out once we have the different clear areas of work, and then maybe we could throw small teams. Of the groups, is it a pretty good spread between the different engineering disciplines and chemistry and stuff like that?
So that number that I gave of like the 20, 25 is based on like my people have come and spoken to me.
Mhm.
So I don't really know which of this they're falling under and stuff like that, but all of them seem very passionate. So like, we can dedicate a team of 3 or 4 people to just go and work on a sub project if you want to. Like, is this going to work? Let's give it a try. Stuff like that. So no, I think they're all very passionate people that are engaged. So I that number, usually in the past it's been pretty evenly split, although not a ton in the programming team, but that's not a focus we're having right now. Anyway, but generally the split's relatively even.
All right, cool. That's great. All right.
Hey Chris. Hey
Yep.
Chris. So I see that you have the link. Actually, can you share the spreadsheet so we can
Sure.
point out where the chimney material is? Because
Yeah.
I think it would be really interesting to, well, not interesting, but it's an important task to look at this chimney material, like if we're going with it. So yeah, it's like there. The stainless steel. Yeah, you have your mouse on the cell. So so that's the section where it is like under tube material. Um, like
Yeah.
you all can hopefully find this link. If you don't have the spreadsheet, we'll post it on Discord maybe. And when you click on the link, there are a lot of different like connector types and stuff, like shapes of it's basically like tubing. Like if you're familiar with air or water tubing, it's pretty standard, it seems. So I'll think about how to like getting us like quote unquote set of these parts to hook it up so that it would do maybe like what David said, or maybe I'll think about like I'll look at it to see if it's possible to do what we need in
Yeah.
any way. And I'll make that my to-do item, but anyone else can feel free to also do it. You'll learn a lot for sure.
Yeah. I didn't think I would learn so much about chimney parts in the last week, but that's part of the fun of it.
I like the idea of the double wall. So should we focus on the double wall?
Yeah. Yeah.
I think we do need the air as insulation, or like
Ooh.
maybe
Could you use the double wall part could that outer layer, you were talking about a pipe, but with that extra space like that, could that have any benefit in air recirculation?
I wouldn't do that. You'll get a lot of heat loss. I was thinking we need the double wall because air is an insulator.
Yeah. Okay.
And we need all the heat insulation that we can get.
Okay. Sounds good. All right. Well, one other thing I wanted to just sort of, if you guys will indulge me on a little bit, we talked about the clay idea. I think we should just go with the chimney part, build that, get a working unit, and obviously keep an open mind to other ways we can make similar parts. And I did, that same guy, Malks, who shared the diagram of the wiring. Hopefully he can join us on one of these calls one of these days. Very bright guy. He shared a 3D printer for clay with me, and I've already been in touch with the company, and they have got like a 2,000 member community on Facebook. So I actually posted, if anybody's joining us of the 5 people here, I did post this live stream there, and I'll show you a picture of it in a second. Before I do that, one thing, Seth, when I go to UPenn next week, since we're on sort of hold with what we exactly do there, we're really moving full speed right now with UT. I'm going to go ahead and grab that, our new sensor, which we ordered. And if we need to replace that at UPenn, we'll do that once we have a team in place. But I'm going to go ahead and grab that. And so if there is any kind of, I'll bring it to the UT team here. And if there's any kind of testing we want to do or playing around with it, we can start kind of adding that to the agenda if need be. But yeah, let me show you this thing here. I think it's pretty cool for a couple of reasons when we think of big picture. This here, if you guys can see that, it's the company's called Ezao. They're based in China. They were produced through, I guess, one of the largest crowdfund efforts ever. That's how they started. But they have a variety of different clay and ceramic printers. This is the biggest one. But the parts it can make, you can kind of see the dimensions of the work area here. And this little video, which might actually play. Oops, I don't know if you guys can see that. Can you guys see that? Is there a YouTube? So it's pretty cool. And then when I talk to the manufacturers of it, there's a lot of flexibility on what you can put into it in terms of clay mixes. And one of the things I researched on the side is, as a long-term goal, we have this idea of mineralizing CO2 right on the bottom level of the unit. And we talked about that a little bit. Kirsch led us onto brucite, and I researched that a bit. Brucite is great because it's relatively cheap. It's cheaper than wollastonite, and it has a really fast reaction time. And when you add CO2 to brucite, it reacts and turns it into calcium carbonate and silica. And then I just did some research on it, and they already add calcium carbonate and silica to clays because it increases the strength of it and the finishing of it. The only problem is when you have to put it in the oven, normally you have to put it at temperatures that are high enough that actually cause the carbon dioxide to decompose, which we wouldn't want. But there's other ways of doing it where you can add polymer beads to the mix, that particular kinds that actually reduce the temperature below 825, which is the sort of when the decomposition happens, where you have you don't have to get it that hot in order for it to heat up enough. And I then looked into some of the providers of these polymer beads, and there's a company that I know quite well, actually. I know the guy who founded it, called Lanzatech, which makes those polymers out of CO2 from industrial sources. So they actually capture it, and they make them in these little beads. And so anyway, there could be a world in which we look at using printing out of clay some of the basic geometric parts, and that we actually add the mineralized material, the calcium carbonate and silica with that other one, into the clay that we use to print out the next one. You know what I mean? So we're storing the CO2 from our one DAC in the next one that we make. And there would be cost reductions, obviously, down the line if we invested in a, $3,000 dollar piece of equipment. Then it's basically mostly clay and some other stuff. So anyway, that's a bit of a quixotic sort of idea, but could be a very cool one. It kind of goes back to some of the original things we were thinking about 3D printed DAC and mineralization. So I'll keep pursuing that, but wanted to just put that in your guys' brains because I thought it was a cool idea. Let me know if you have any questions. And clay can go extremely hot. The only limiting factor there is it doesn't sound like we need a lot of vacuum. So if we did it thick enough, we wouldn't, crack a brittle clay probably with a little bit of vacuum applied to it. So anyway, that's my weird idea. We'll keep you posted if anybody bites on it from the EZOW community, and we can pursue that at a later date. Cool. Anybody have any other kind of questions, ideas, things to discuss?
Not like questions or ideas, but when are the students meeting again next week?
We meet tomorrow from 5 to 6 Central Time.
Okay. So do you have access, Thomas, to the spreadsheet of parts?
Yes, I think you just sent it in the chat, right?
Okay,
Yeah.
awesome.
Yeah.
It's also on the Discord if you're on the Discord.
I
am. If not, let one of us know. But I think it would be good for them to look at the spreadsheet, and the ideas are everywhere. It's like probably kind of disorganized, but I'm sure that when a lot of brains are put together, everyone will have wild ideas, and it will help with the diversity. So I would say maybe you can share this with them. Let one of us know if we need to jump on a call with the students and explain. But yeah, they're like, it's kind of modular, right? Like you have heating, and then you have housing, you have ceramic monolith. So Okay, so I will look into the chimney components. And I forgot to mention, I didn't notice this. There's an extra tab called chimney components. I assume it's from when Chris called up these people.
Yeah, yeah.
So I'll probably add my ideas there on like which ones we should buy. I'll probably look at those too. Look at your notes.
Yep, that sounds great. A lot of good videos from that provider. Northline Express is an online retailer of parts that are made by Dura. What the hell's it called again? Dura something. And they created a whole bunch of videos on YouTube that really shows it up close, how they fit together, and all that stuff. And that's one of the things that made me sort of fall for it, being able to see those. So if you look up Northline Express, and you can see some of their YouTube videos and how all the parts fit together. But Ling, you'll see total range of any of the part sizes we'd want, with 8 inches or 10 or whatever we want. So
Yeah. Okay.
I was
Yes,
just gonna say.
Yeah. Sorry. Go ahead.
No, I was gonna say, to your point, I know you were concerned about making sure that the people building the machine are also the ones involved in the design process, and I appreciate that. I remember you expressed that a few meetings ago as well. But not only, we'll do that, and we're also gonna make sure we're currently constructing a to-do list and organizing a lot of the thoughts in the Epiphyte chat for the students and things like that. But I'm also gonna encourage them to watch these meetings as well. And I know Chris is super good at watching the chat and stuff like that, so they'll be involved that way too.
Yeah, that's good. We're kind of disorganized, so maybe when people have actual needs, it'll whip us into shape.
Maybe.
We're not that disorganized.
I think it's pretty organized. But.
Yeah, I think we're relatively organized. I think that the thing that'll be the real game changer is when we have parts ordered, 20 students in a lab, and we're actually having to think through the practicalities of how does this fit onto this and how do we troubleshoot that. That will focus the mind and the to-do list quite a bit. So we'll talk about all this stuff tomorrow. Hopefully I can swing by for a bit and meet the other students. My 13-year-old will be in tow, but he's quite a geeky CDR-loving guy himself, so he'll be into it. But yeah, that's about it. But I am absolutely thrilled.
Sorry, I have more questions. What is our budget? I don't know if it's like from the open air side or the school side, because I want to know if we can buy multiple like heating options or stuff like that.
We have $4,000 that we got from the Bezos prize, which so we can hit that. And looking at it, I think we're going to be safely below that, with what we're looking at. So that does give us some options to buy different parts to, play around with.
Yeah, and if we have the fan double, we can save a bit of money. And then I'm thinking we should buy maybe more than one like heating option, just in case things fit weirdly or whatever. We'll have to decide, but I think the heating is one of the harder things to decide on.
How do you feel about, and if you guys want to take a look at that heater I have in the bomb there, it's the top one. I called up that company. It's called a nickel chrome flam duct heater. And the good thing about that is it can get to a really high temperature, where HVAC stuff usually kind of taps out at around 60 or 80 C. So we want to get, for PEI, it's between 100 and 120 is for adsorption. So that was just one that I found that I thought was small enough. Air can flow through it if we needed to. It's cylindrical. But if that's things that students want to do, is maybe look at some other options, would be good.
So I'm not against that one in particular, but I'm thinking about modularity and being able to take this apart and putting it in another setup, or like shuffling things around. And I think the shape of this is not as conducive to modularity because the diameter is small. I'm not like canceling this idea, but I'm just saying that like I want to have a few options in mind and think about like if we want to shuffle things around, what would be the most conducive to building things modularly. We want if our fan is large, we want the heating element also to be large so that it would push a lot of heated air, like a lot of air through a heated cross section and distribute the heat faster. That's just what I'm thinking. But I'm not like, if other people have a way to integrate this I just can't think of a way right now.
Yeah.
I'm all for like getting it anyway and just having it on hand just in case. Which is why I asked the budget question.
Okay. Yeah, let's just keep looking at it. You know, if you guys have, you know, that could be a thing that a group could put a little more. I probably put in, you know, 3 or 4 hours kind of looking around at different options, but
Yeah.
it's got to get to that heat. You got to be able to adjust it. It's got to fit within what we're doing, and it's got to be not insanely expensive. Those are basically the criteria.
Yeah. Yeah.
So, before we jump, I just wanted to say, I would love to talk to you about crowdfund options. I think that could happen in many different ways. J3ANX is that, you know, the goal of this is once we get one that we think is workable enough, then it's about trying to get as many teams as possible to build these at universities and other places. So you can imagine crowdfunding that's more family and friends for a team that wants to just raise its $3,000 to build one, or a larger crowdfund that would allow us to then disperse, you know, funds to multiple teams. But hit me up on the Discord if you have anything to elaborate on that. But yeah, thanks for thinking ahead on that. All right, dudes. See you guys later. Great seeing everybody, and hopefully I'll see you two folks tomorrow in person.
Sounds good. Keep us updated.
Bye,
See you,
everybody.
Chris.
Thank you. Bye.